annotations can be very useful for many purposes, and they don't have to change the semantics, and it's fine if they don't change the semantics of the underlying operational bytecodes, but they can tell you certain properties that that program would have. Like this thing is always pointing to this subclass. And furthermore, so I asked yesterday about an idea that had shown up in .NET briefly, it seems to be gone now, which is that you could have bytecodes with one set of operational semantics, but different styles of metadata for it. For example, if it's the same underlying semantics. Not such a bad idea. So just to answer those questions with straight answers, I think it might be fine to assume that you can't trust the metadata, but it's telling you something that you couldn't have derived anyway, and you can check. And that they don't have to change the language, but they can still tell you things about properties of your program that are true anyway in the language, but you couldn't have necessarily derived. And that's why you don't have them proven statically rather than using attributes, because you couldn't necessarily rederive them so easily.
Right. Great. Yeah.
So I've got a question. Look at the first bullet. The question of whether all languages targeting one VM, does that really make sense? And I guess the question I've got is, languages are more than the base language. They're the set of libraries that go with them. If the libraries, if you've got a large collection of libraries, and we're getting increasingly large collections of libraries, do the libraries really intermix? So for example, Java has a notion of reflection and generics. One of the, I think that I remember hearing a talk recently about the way generics were shoehorned into Java, and the intention was to put them in such a way that the libraries continued to work. This was hard. Well, now let's imagine that C# has done generics in the, quote, proper way that we'd all agree with if we were to redo Java. And now I pass an object to C#, because, can it do things that Java isn't allowed to do that'll mess up the libraries in Java? That's probably not a good example. Maybe things like reflection are better examples of, where there are guarantees that the libraries assume are being made, but another language allows you to violate those guarantees. If we start passing objects back and forth, do we destroy the assumptions that the various libraries have embedded in them? If we don't pass them back, the information back and forth, what's the point of unifying everything? And so
I can answer a little bit of it with maybe a better example. So one of the things you cannot do in Java is you cannot say for some arbitrary object X is X an instance of list of strings. You can it actually syntactically you can't even ask that, and the way it's compiled, the only thing you can ask is it a list? The of string part does not appear, and this is a difference between generics done with backward compatibility and generics done quote right, and it shows up exactly only there in all of its ramifications. Well, this is going to hurt interoperability with C# if they do it quote the right way, because C# code that gets this collection, even if you have an interoperability layer, the answer is not there. The Java runtime does not know the answer.
Bigger?
I think one of the issues that would be worth talking about is how can you separate out sort of the policy requirements that you have for specific languages from the mechanisms that implement them. I think JVM was designed for one language, and there's a lot of sort of conformity between what the JVM rules are and what the language requires. If you look at MSIL and the common language runtime, it matches well with C#, but it's not clear that it matches well with other languages. And part of the reason is a lot of the policy is defined at the CLR level, and now has to be used for multiple different languages that might really not require exactly the same policy. can we factor out virtual machine architecture so that you're separating the policy to one language or a small class of languages, so that each class has its own policies, implemented on top of a common architecture that provides mechanisms. And mechanisms could include compilation, garbage collection, exception, many things that are pretty hard. Do you think that's possible, and is that the right way to do it?
Oh, it's definitely possible. That's actually what I'm doing for Parrot with my project, and that's something I'm not going to talk about tomorrow either. Where basically, you know, we've got looking at a situation where we have languages that have a certain level, certain set of constraints, and those constraints we don't enforce at the virtual machine level. You know, for example, we expose a lot more reflective and introspective capabilities than necessarily the languages want. And our assumption is, you know, we provide the mechanisms because, to some extent, for writing the libraries, we need the mechanisms. So the mechanisms are there. We are not enforcing the policy that says you cannot do X. The assumption is if a language doesn't want to let you do X, the language won't let you do it. You know, if you have a language that, you know, we support continuations fully. And if a language does not want to support continuations, you do not expose syntactically the fact that continuations even exist. But that does not preclude the libraries or libraries written in a different language from doing, you know, from using them or using any of the other features. Our assumption is that if you're doing something, you know, we're using an object whose class is completely defined in a different language, you don't really care what happens to make that method call work. The fact that the language is doing 8 things that you think are horribly vile doesn't matter. It's all magic. It's behind the method call wall. And, you know, we know at some point some clever person is going to extend all the languages to expose all the features the language designers thought were a really bad idea. But we're kind of in a more, you know, free-form environment for this sort of thing where we know if we don't let people do it, they're going to do it anyway. So we might as well just give in from the beginning and, you know, make our lives easier rather than, you know, try to enforce the policy that we know 2 years from now someone's going to hack out with a rusty axe anyway. So.
Well, I think continuations are fine idea to consider. You know, if you're really thinking of a language, one VM that's going to, you know, support lots of languages, are you going to do continuations? And are you going to do multiple continuations of the form that, you know, you could run Prolog in, for example? 10 years ago, Prolog was dead, but it's not dead anymore.
Prolog's never died.
Yeah, okay.
Brother-in-law does a lot of
David?
Prolog work.
I mean, if you look at Doug's example, and what Mark said, most of the problem seems to come from introspection. That if you go messing with one of these objects from the other side and try and look beyond its interface and ask it questions like, what are you really, and what are your parts? This is when you're going to get the answers that you're prepared for. And you can even see this now in Java bytecodes. If it was possible to introspect on the bytecodes and ask questions like, what is the type of the element on the top of the stack? I worked on a VM that's capable of giving you an answer that cannot be expressed in the Java type system. And that's just an artifact of how bytecodes are generated. But you've got it, you know, right now. And if you thought that you shouldn't ask those questions if you're not prepared to get can't tell you answers.
Just following up on that point, I think you have this bullet about why not have them proven statically. So obviously we should harvest whatever we can statically, but we know that there are going to be properties that have to be checked dynamically. So array bounds checks, there are many cases when we know we can eliminate them statically, but we will still have the runtime check as a default. As a very simple example. Security, we know that the checking really does depend on the calling context. You can try and develop new type systems, but ultimately if you want to write libraries that are usable in different contexts, you need some runtime checking. So I don't see how we can get away from runtime checking, much as we might want to minimize it. If you want code that's really usable in production, middleware.
Okay, so, okay.
We briefly mentioned last night a fairly good approach to this that there's an USLA paper on that sort of doesn't, at least make some strides, is to have extensible verifiers, to have people tell you what they think should be verified for this code to run, and that allows you to play exactly the game Andrew was talking about. if you have a quick way of verifying immutable, then extend the verifier and help out the VM. And maybe the VM will say, no thanks, I didn't want to know that, I'll find out myself. But that's only part of the issue. A lot of annotations are used for static analysis tools, verification tools, software engineering tools, where that non-null or immutable is very important design information, and whether the VM needs it, well, the program